Welcome back. We're still working on time series analysis and forecasting. And in this example, we're going to tackle some seasonal variation. And we're going to do that by creating some seasonal dummy variables. So I've got data on smartphone sales in thousands of units or thousands of dollars. And I've got data for 4 years. In format, you might have to use the copy and paste function to get it into this format. And there's another video on YouTube that will show you how to do that. So now that I've gotten my data into this format, I want to plot it so I can have a sense of what it looks like. And this should be your first step whenever you're giving any time series data before you take the process of forecasting. So temporary time variable. And to do this, I'm just going to sequentially number all of the quarters in my data set. So I'm going to start by counting down 1, 2, 3, 4 manually. Then I'm going to highlight those and right-click in the corner, and Excel will just continue that pattern down. So I can see that I've got data on 16 quarters. Plot the demand. First, I'll hold down my time variable, then I'll hold down Control, and I'll highlight my sales. Select a chart, and I'm going to choose a scatter chart with straight lines and dividers. I'll rename this early smartphone sales. And then I'll label both of my axes, sales and down here I've got quarter. By 2, and I'd like it to go up by 1. So I'm going to change the units, the major unit, from 2 to 1, and now every quarter is labeled. Fantastic. So when you look at this, I'm hoping you see 2 patterns. I'm hoping you're seeing both a seasonal fluctuation, a regular rise and fall, so a slow increase over time. And we're going to tackle this problem in 2 parts. First, we're going to focus only on the quarterly fluctuations, on that seasonality, and in the next video, we'll deal with that time trend. So to start, our first step is going to be to create quarterly dummy variables. Columns E, F, and G. And I'm going to label these quarterly dummies. And I'm going to have one dummy variable for quarter 1, one dummy variable for quarter 2, and for my first observation, a 1 in the dummy for quarter 1 and zeros for 2 and 3. For my second observation, which takes place in quarter 2, 1 and 3, and a 1 in quarter 2. Like it's saying yes, it's indicating membership in a given category. So here the category is quarter 1, and this first observation belongs in that category, so it should have a 1. We can do this by creating an if command, and we just say that if the quarter of our current observation is equal to the quarter that we're looking for in that variable's category, we want Excel to return a number 1, and if not, we want it to return a 0. I'll close my parentheses, and that formula would be great if I wanted to leave it as it's on its own, but I'd have to re-enter it in every cell. I want to be able to drag it to the right and then drag it down. So when I drag it to the right, I don't want my reference to leave column C. I don't mind if it referencing value in the current observation. So I'm going to place a $sign. I'm going to fix the column. Same thing with to be able to drag left and right, but I want it to stay referencing row 3. So I'm going to place that $sign in front of the 3. Drag over. All right, perfect. Let's just take a moment to make sure that this worked. I'm going to write my ninth observation that takes place in quarter one. It has a 1 in the quarter observation. It has a 1 in the second column, indicating that that observation took place in the second quarter. Observation, which took place in the fourth quarter, all 3 quarterly dummy variables, right? That observation is not quarter 1, quarter 2, or quarter 3. So that looks good. We're good to go. We also see this kind of regular diagonal pattern of 1s, and that's indicative that it worked also. Make sure that your dummy variables worked before moving on to the next step. What I can do is predict sales. This is our y variable as a function of the 3 quarterly dummy variables. And we can think of these as x1, x2, and x3. Under data, we'll go to data analysis, and then we're going to scroll down and find regression. Find that, click OK. And the regression box wants a few inputs. So input y range, where is that y variable that we're trying to predict? Well, we're trying to predict sales. So I'm going to highlight sales, all the values, and its heading. And then for my input x range, I've got a multiple regression here because I've got 3x. Highlight their headings or their labels and all the data. I'm going to make sure down here that I've got labels checked. Where do I want this result to go? Where do I want the output? I want it just on this worksheet, and I'm going to put it down here in row 21 because I want to keep it close. That's done. I say OK. And then I'm going to scroll down and take a look at our output. Change all of our numbers here to deal with. Draw our attention to the piece of this puzzle that we're really interested in, and that is these coefficients. We're going to ignore the rest of the table for now, because these coefficients become how we make our regression equation. So 3. Our beta 1 is negative 1.8. Our beta 2 is negative 2.33, and our beta 3 is negative 0. I'm going to hide these rows. My coefficients. Now I'm going to enter my forecast. I'm going to use standard linear regression formula. And anytime I reference one of my coefficients, I'm going to absolute reference them. Start here by our first value is going to be equal to the intercept, absolute reference, plus x1 plus beta 2 plus beta 3 so all of our coefficients, which are down here in column B, have an absolute reference. All of our x variables, which are here in row 4, I hit enter, I'll get my forecast. So what this is telling us is forecasted demand for quarter 1 would have been 0.725 thousands of sales, much higher than the actual value. If I drag these down, our historical forecast. Patterns I want you to see here. Well, actually, there's one pattern I want you to see, and then a couple other things. So for every single quarter 1 value, is forecasted at the same level, right? Same with every quarter 2, every quarter 3, and every quarter 4. And variable here, a regular pattern of ups and downs, of ebbs and flows without any change in trend over time. In fact, we can add this call it and its series X values are my values for time. Series Y values are the values of the forecast. Now we can see them superimposed. A regular original data blue. Change the forecast by formatting my data series so that rather it being a line with a color, I'm going to change it to a line. That will make it a little bit easier to see if you're on a black and white screen or if your eyes think that red and blue look like a forecast that just repeats itself every year. It doesn't trend upward, but it does a pretty good job tracking those seasonal variations. How well does this forecast do? Add a few more rows here. Learning how to calculate and interpret all of the error terms and all of the error summary terms. You can see another video, which is linked on Canvas or on YouTube if you're not in my class. But in this example, we're just going to focus on so I'm going to calculate my error, which tells us how well or how unwell we did in the forecast. And then I'm going to calculate the squared error. Our error is just equal to actual minus forecasted. So our actual value of sales in quarter 1 was 4.8, and our expected value was 5.73. See that in the first quarter, overestimated by 0.92. Our forecast was higher than the actual value. And we can see that in the beginning, our errors tend to primarily be negative, which reflects what you see in the chart, which is that in the beginning, we primarily overestimate. And that's because we're looking only at seasonality and we're not encompassing, or we're not accounting for that trend. Whereas in the second half of the data, we're primarily underestimating, right? These errors are positive, and you can see that our forecast line is below the actual line of sales. Underestimates and overestimates will balance each other out if we average. We can square the errors. And to square the errors, we use the caret, which is shift 6, and then the number 2, which is basically saying that we want the error to the second power. Here are our squared errors. Calculate 2 summary measures. We can calculate the mean error by averaging the errors. And in linear regression, this number will equal 0. And then if we drag it to the right, we can get the mean squared error, which in this example, I'm going to add a top border here to indicate that we're going from a place where we've got numbers to where we've got summary measures. And this is the mean error, and this is the mean squared error. We also have our coefficients. We'll forecast. You know, what if we actually want to know or estimate what's going to happen in year 5? So in year 5, I'm going to create hypothetical values, or I'm going to create, they're not hypothetical, I'm just going to set up the problem. We stretch off into year 5, that's going to be our quarters 17, 18, 19, and 20. And we're going to have, again, in year 5, quarter 1, quarter 2, quarter 3, and quarter 4. And my dummy variables and my forecast populated automatically. You might have to drag down some formulas. It won't surprise you because every value for each quarter is the same in our forecast. So we'll see quarter 1, quarter 2, quarter 3, quarter 4. Those mirror exactly the forecasts we had in the past. That new forecast, this chart, your estimate values would be our time value. My y values would be, and grab the last values to make sure that my line's connected. Right? And now you can see that forecast in the future continues that exact same pattern. And I'm going to change this so that it's a dashed line. And there's the future estimate. Probably already realizing that this estimate is all forecasts are, but count on this increase in time, right? We're not accounting for the trend. So pop back in the next video and I will show you how to also add a trend variable. And then we will forecast and a trend. All right, see you shortly.